called as sources of energy. For everything that we do, we require energy. Everything. Okay. Human beings, they take their energy from food. So that's why it is essential for us to understand that what are the different sources of energy, what are their characteristics, and how we can utilize them. So the first thing that we have to study, what is a good source of energy? A good source of energy is the one having the few characteristics or desired characteristics. The first characteristic which you should write in your exams is high calorific value. What do you mean by high calorific value? It means that if I burn the substance, I should get more amount of energy. In general, heat energy. So that is called as your high calorific value. The first important point. The second one is moderate ignition temperature. Okay, that is, if I say moderate ignition temperature, it means it should not start burning after a very long time or readily. In both the cases, it is difficult. Okay, now it is easy to store and transport. It is better if I have a fuel which can be easily stored. The problem with the nuclear fuel like radioactive material is that they are difficult to store. Easy to transport. It's easier if I can transport from one place to another. What will happen? It becomes easier for me to transport, my cost reduces of transportation. Then it is easily accessible. That is, you can find it at a lot of places. Again, the problem with the nuclear fuel is that it is not readily available. In India, it is only found at one place, that is a district in Jharkhand by the name of Jaduguda. Okay. Now, the next thing is economical. The fuel should be economical. That is, it should not be very costly, because it is not possible for everyone to afford a fuel which is highly costly. Cost part is there with that. And it should be least polluting. That is, the pollution created by the fuel should be minimum. Now, one thing I want to add in this, I am not saying the fuel should have all the characteristics. There is no fuel which can have all the characteristics. But if I can have majority of these, the fuel I will say is a good fuel. Okay. Now let me come to the next thing, that is the exercise in the book which says what is a good source of energy. We did this question. As such, high calorific value, easily accessible, economical, least polluting, easy to store. What is a good fuel? A good fuel is a fuel which produces a huge amount of heat on burning, does not produce smoke, okay, and is easily available. That is the characteristics of any good fuel, is defining the good fuel itself. Next it is, if you could use any source of energy for heating your food, which one would you use and why? See, if I have to use, I will use one which is economical, least polluting, if I am giving that, and high calorific value. The three major things which I require: high calorific value, easily available, and economical. Okay. Now let us come to the next thing, that is the conventional sources of energy. Conventional means which we use normally. The first one is fossil fuels. Fossil fuels are your coal, petroleum, LPG. They all are called as fossil fuels. I hope you people know why they are called as fossil fuels. They are called as fossil fuels because they are obtained from the dead remains of animals and plants, and they are formed by the under very high pressure. In the time limit which was required for millions of years it took to get them formed in the place which they are right now, and the current position also. Now, what are the advantages of these fossil fuels? The first advantage is high calorific value. And the second one, again a very important thing, which people say they create pollution. I agree, they create pollution, but the pollution created by them can be decreased by increasing the efficiency of combustion process. That is, if you are providing more oxygen, you are increasing the efficiency. Okay. And using various techniques to reduce the escape of harmful gases. By increasing the height of the chimney, you are reducing the pollution. Okay. The disadvantage, the biggest disadvantage with them is they are non-renewable. Okay, that means if they are once used up, it takes a lot of time to get them renewed. It's millions of years. Okay, the current data says that petroleum, the known deposits of petroleum will get over in 50 years time, and the coal deposits will get over in 200 years time. The known one. Okay, so that's why big problem. It's non-renewable. They create air pollution. If coal or petrol, whichever is burning, they create pollution. And acid rain. I hope you people know about acid rain. What happens that from the vehicles, nitrogen oxide and nitrogen oxide, carbon dioxide, they both go, and sulfur dioxide. They stay in air. Now when rain comes, they mix with water and become your nitric acid and sulfuric acid, which comes down, and this is called as acid rain. The next one is global warming. That is, carbon dioxide is a greenhouse gas. So it results in global warming, that is the temperature of earth is increasing because of this. Now, next is thermal power plant. What do you mean by thermal power plant? Thermal means heat. So a power plant in which heat is used to generate electricity. Fuel is burned to produce heat, which is converted into electrical energy. Fossil fuels are burned in power stations to heat water to produce steam, which runs the turbine and electricity is generated. Let me give you a small demonstration for that, which is with the help of this diagram, which is again given in your NCERT book. Take a pressure cooker. Okay, put some water in the pressure cooker and put the pressure cooker on the gas stove. Okay, then what you do? You ignite the gas stove, it starts burning. Okay, the gas starts burning and water will start boiling. Now, because as this pipe is connected with it, so what will happen? The steam which comes out is directed to this tennis ball arrangement, which represents a turbine. So the turbine starts moving, okay, and because of the movement of the turbine, the dynamo moves and the bulb is there and the bulb starts glowing. That means electricity is produced. Okay. Now the next is hydropower plant. Before telling you about hydropower plant, I have to tell you one thing, that majority of thermal power plants are near the coal mines. Why? Because the cost of transportation is reduced. Okay, that's why we do that. The next one is called as hydropower plant. Hydro means water. So what we are doing, it converts the potential energy of water, stored water, into electrical energy. Now what is happening? Hydropower plant, what it does? It converts the potential energy of water to kinetic energy. The kinetic energy is converted to electrical energy. So you are getting electricity from water. Let us understand this concept. Here at a reservoir, basically a reservoir is nothing but a dam normally. Okay, water is stored. Then what happens? That the water is allowed to fall from a height. So when the water was stored, it was having potential energy. When the water starts flowing, the potential energy converted to kinetic energy. So the water is flowing. This is the turbine. So flowing water will move the turbine. When the turbine moves, the generator will have, or the dynamo will generate electricity, and because of this, through the power lines, it is sent to the power stations, and from the power station to the sub-power station, and then to your homes. Okay, it is the high-rise dams are constructed on the river to obstruct the flow of water and thereby collect water in large reservoirs. The water level rises, and in this process, the kinetic energy of flowing water gets transformed into potential energy. And then, as I told, the whole process, it takes place. Advantage, the only advantage is it's a renewable source of energy and free of cost. Except if I am not taking into account the construction of dam and that cost, but if I take water as a source, it's free of cost and renewable. Now, what are the disadvantages of this? The biggest disadvantage is the construction of dams. Okay, now dams can be constructed only at limited places. You cannot construct it everywhere because you won't find water everywhere. Okay, so dams can be constructed only in a limited number of places, preferably in hilly terrain. Okay, hilly places. Now, second is large area of agricultural land and human habitation has to be sacrificed. What happens if you are storing water somewhere? What you are doing? From that place, the flora and fauna is gone. Even the human habitat is gone. Okay, so that is a problem. The next problem is large ecosystems are destroyed when submerged under the water in the dams, as I said. Okay, now the vegetation which is submerged rots under anaerobic conditions. Okay, anaerobic, that means there is no oxygen, so it will rot, and because of its rotting, what will happen is that the water as such, it starts decomposing, and because of this what will happen, methane gas is produced. Methane is a greenhouse gas, so indirectly what is happening, the global warming is taking place. Okay, the one more problem is that the proper rehabilitation of the people is not done, and the compensation is neither adequate nor on time, which is again a problem. Okay, so this is about your water, okay, hydroelectricity. Let me come to the next thing, which is called as biomass. Now what is this biomass? It is the biological material from living or recently living organism, that is which are living or which just died, that is called as biomass. So you all are biomass. Okay, example, wood, animal waste, plant waste, this all is biomass. Now the one thing that is a problem with them, they don't have high calorific value and they produce a lot of smoke, so which is a problem. So this is not an advantage associated with them. Now the important thing is they can be converted to other forms of the forms to be used as fuel, that is wood to charcoal and other thing you can convert. So that is an advantage. It is having low calorific value, convert it to some other form having high calorific value. The example being charcoal. When wood is burnt in a limited supply of oxygen, water and other volatile materials present in it get removed and charcoal is the residue left. So what is the benefit? It's a good thing. You are using the destructive distillation of a limited supply of oxygen, means destructive distillation of wood. So what will happen? Water, it goes out, okay, and the other volatile gases or something, they also go out. What remains, the residue, is called as charcoal. Now what are the advantages? One of the biggest advantages, it is having a higher heat generation efficiency. That means it will generate more heat as compared to wood. The same wood was not generating the amount of heat that we require. It will generate. The next thing, it burns without flames. That is no smoke concept. Okay, it's a clean fuel in itself. And the third one is, it is comparatively smokeless. If it is flameless, obviously it won't have smoke part. Okay, so this is one thing about your charcoal. We converted the biomass to a fuel. This is one conversion. Because what happened, when we were using conventional sources, we found out they are limited and there are problems. So we thought that why not to convert them or to modify them. So one modification was this one. Okay, there is one more, which is the next one, called as biogas. What is a biogas? A biogas is a mixture of four gases: carbon dioxide, methane, hydrogen sulfide. These four gases. So the cow dung, various plant material like the residue after harvesting the crop, sewage, vegetable waste are decomposed in the absence of oxygen in a biogas plant. Okay, and it is used for lighting, okay, and as a fuel also. There are two types of biogas plant, but in your syllabus there is just one. Okay, so first of all, let me share with you what are the advantages. I will share with you the working also, but first I will share with you what are the advantages of a biogas plant. The biggest advantage of biogas, it's an excellent fuel. because it consists of 75% of methane. Okay, and methane as such is having very high calorific value. Okay, second thing, it burns without smoke, no smoke, clean fuel. Okay, third, leaves no residue, again clean fuel, so there is no residue part with it. Fourth one, high calorific value. As I told, methane is having high calorific value. So biogas, as 75% is methane, so it will have high calorific value. Now, one more thing, the slurry left behind, it is an excellent manure which can be used in the field. Okay, that can be used in the field as a manure. And one more thing, the biggest advantage is that it's a waste management plant. The waste as such was just lying here and there, not used properly. You are using it properly. So it's an efficient method of waste disposal. Okay. Now let me come to the topic of how a biogas plant works. This is the diagram of a biogas plant. The same diagram is there in your NCERT books also. So let me focus on the diagram. First thing is this part. Okay, what you are doing, the slurry. Okay, the waste which you are getting. Okay, every day it's the biological process. Everyone excretes. So the excreted product of plants and animals, it is collected. It's not just for one person. It can be collected for a whole village or something. We are collecting it, and then water is mixed with it, and it is mixed with water to make it uniform, completely mixed. Okay, then what happens, that it goes inside the earth. Because this complete is a biogas plant, this is just one part, so this part goes down here. Okay, and in the absence of oxygen it starts degrading, decomposing. So what happens, day by day it starts decomposing, and as I said, it's a biological process. Okay, unless the whole village is having constipation, the the biogas plant will definitely work. Okay, so definitely every day it's coming, and what will happen, it keeps on adding. So let me take the 15th day. So what came on the first day, it has decomposed, and because of its decomposition it became light. So what will happen, lighter things always come up, the heavier things they go down. So the heavier one goes down, the lighter one comes up. Okay, and the gas is again, because of this decomposition, biogas is formed. So this is the place where gas is formed. Now what happens, from this gas outlet you can take out the gas. Okay, you can fill it in the cylinders or whatever is the arrangement. Now what happens, the next thing is that the first day decomposed, it will try to go out from this place. Okay, here it comes out, and here it is taken out and used in the fields as a manure. Okay, so this is the working of a biogas plant. Okay, consists of mixing tank. This is called as mixing tank. This is called as digester. Sealed chamber in which there is no oxygen. Okay, it is a dome-like structure made with bricks. A slurry of cow dung and water is made in the mixing tank and sent to digester. In digester, anaerobic microorganisms decompose complex compounds of the cow dung slurry. It takes a few days for the decomposition process to complete and generate gases like methane, carbon dioxide, hydrogen and hydrogen sulfide. By the way, I think all these four gases constitute a gas called as biogas. Okay, the biogas is stored in the gas tank above the digester, from which they are drawn through pipes for use. The left behind is used as a manure. So this is your biogas plant. Let me come to the next thing, which is wind energy. Now wind energy as such, again it was a conventional source of energy which we modified. The unequal heating of the landmass and water bodies by the sun causes the wind to flow. This can be a question in your papers, that how is wind energy obtained from the sun, or how is sun responsible for the wind energy. So the unequal heating of the landmass and water bodies by the sun causes the wind to flow. In the windmill, the wind rotates the blades. Those are the blades, okay, of the turbine. Now what will happen, that blades of the turbine are rotating. So what will happen, it turns the turbine and electricity is generated. Problem, the electricity generated by one single windmill is very small. The output is very, very small. So it can't be used for commercial purposes. So what should we do? We connect a large number of windmills are installed in a large area, that is called as a wind energy farm. Okay, and their output is combined or coupled together to get electricity on the commercial scale. Clear? So this is the case of a wind energy farm. Now let us see what are its advantages or disadvantages. Advantage as such is one, renewable, free of cost. Let us come to the disadvantages. The biggest disadvantage is it cannot be established everywhere. It can only be established where wind blows for most of the year. Okay. Second, the minimum wind speed required is 15 km per hour. Okay. It is the wind speed required to maintain the required speed of the turbine. Next thing, backup facilities are required when wind is not flowing. You cannot have that if wind is not there, we cannot have electricity. You require backup. Backup requires cost. Okay. Then the blades require high level of maintenance because they are made up of steel or any other thing. So because of wind, water and everything, they require maintenance. Okay. And requires large area of land. That is, for 1 megawatt generator, you require 2 hectares of land. Okay, in India, it's usually in Tamil Nadu, but right now in the last few years, there are a lot of wind energy projects which have started in Gujarat. Okay, celebrities like Ajay Devgan and Anil Ambani, they have also set up their plants there. They have invested in wind energy farms in the state of Gujarat. Okay, so this is regarding your wind energy farm. Okay, now let us come to one more thing. Denmark is called as the country of winds. There are a lot of wind energy farms in that country. Now let us come to the next thing. That are the questions. Disadvantage of fossil fuels, I think I have discussed with you people, but again, non-renewable, global warming, air pollution, acid rain. This is a good question. Why are we looking at alternate sources of energy? Because these sources which we are using right now, as I said, they will get extinguished after, or they will get completely exhaust after a few years. We won't find them. Okay, are non-renewable and causes a lot of pollution. How has the traditional use of wind and water energy been modified for our convenience? So as I said, winds were initially used for drawing water or using for the floor mill purpose, but now we are using for electricity. Similarly, water initially it was for running water, was used for nothing. Now we are using for generating electricity. Now the non-conventional sources of energy, the first one is called as your solar energy. Let us talk about solar energy. Now sun is the major source of energy. I will discuss about 1 or 2 sources which are not related with sun. Other than that, all are related with sun. So sun is a major source of energy. Now the case is only a small part of solar energy reaches the outer layer of atmosphere, that is to us. It's not the whole energy that we are using, only a small part of that. Okay. Now there is a thing called as solar constant. Solar constant is the solar energy reaching unit area at the outer edge of Earth's atmosphere, exposed perpendicularly to the rays of sun at the average distance between the sun and Earth is called as solar distance. Okay, and it is estimated to be 1.4 kilojoule per second per meter square, or 1.4 kilowatt per meter square. Okay, this is called as solar constant. That is the value of solar energy for a particular place. We are talking about a particular area. We are unit defining it. Now this is a solar cooker, example of solar cooker. In that, what we use, that inside this, what we use, we take any object, or you can take wood also, anything, paint it black completely. Even the utensils which you are using inside it, paint them black. Okay. Now here you are using a mirror. On top of this, again a glass sheet is used. Glass is used. Okay? And then what we do? We put it like this in the open. What will happen? The light rays from the sun, they come, they enter and they get reflected, they go inside. I hope you people know that black is an absorber of infrared radiation. So what it does, it absorbs the radiation, it changes its wavelength. So what will happen? The high wavelength light can come, but it cannot escape. It won't allow it to escape. So what will happen? The infrared radiation, they keep on storing, and infrared is associated with heat. So what will happen? The temperature keeps on rising, and because of this, food can be prepared. Okay? Now one thing, we cannot use plastic sheet. This comes as a question most of the time in the examination, that you cannot, can you use plastic sheet? No, because plastic sheet will not capture it. Okay? Plastic sheet will allow them to go. Okay, the glass will not allow. Glass only allows it to get in, but it will not get them the lower radiation light to go out. That's why we use glass. Okay, no plastic thing. Am I clear? Now, solar cell. Solar cell, I hope you all know about solar cells. In a lot of solar devices we are using solar cells. A solar cell converts solar energy into electrical energy. A typical solar cell develops a voltage of 0.5 to 1 volt, which is very less by the way, and generates electricity of 0.7 watt, again very less. Okay, so what we do for practical purposes, we connect a large number of solar cells to make a thing called as solar panel. Okay, now solar panels are used in artificial satellites, radio stations, calculators, and anything that you are using, we can use solar cells in that. Advantages, no moving parts. There is nothing moving, you get just a compact thing, you use it. Okay, less maintenance cost, you just put it, it's fine. Next, no focusing device required. Let me share with you, I just skipped one thing. The problem with your solar cooker is that it cannot be used when there is rain, when there is cloudy sky, you cannot use it. Second, you have to change the position according to the sun, which is a problem. Okay. Third thing, the temperature was less, so you cannot do the frying part. These were the limitations of your solar cooker. And the moving part was there. Here, there is no focusing device. It can just be one place, and then it will get the heat energy or whatever it requires. Can be set up in remote and inaccessible areas where putting transmitting power stations is very expensive. Now the problem, the cost of manufacturing is very, very high. Okay, it's highly expensive. Silver is used for connection, and silver is very costly. Okay, and low efficiency of a single cell, that's why we require panels. Okay, now let us come to the next thing, energy from the sea. From sea we get three kinds of energy: tidal, wave, and OTEC. I will discuss all the three. Let us first start with tidal. Low and high tides in sea rises and falls due to the gravitational pull of moon and sun. I hope you have studied this in class 9. The difference between low and high tides provides the tidal energy. Okay, it can be harnessed by constructing a dam across a narrow opening of the sea. The turbine will move because the high tide and low tide, they move. Because of their movement, what will happen? The turbine will move, and when the turbine is moving, electricity is generated. Problem is, it cannot be constructed everywhere. You cannot find tides everywhere. Okay, wave energy. Waves are there in sea. You make the waves to get to one point. Okay, there is a turbine. The turbine moves, electricity generated. Then what do? You get electricity. But the problem again is same, that it cannot be used everywhere, and you cannot set up everywhere. Okay. Then this is the example, or this is the diagrammatical representation of your wave energy. Okay. What will happen? Or your tidal also. That is the turbine. It moves because of sea. You can see the difference. So the turbine will move, and because of that, energy is generated. Now, this is an important thing called as OTEC, Ocean Thermal Energy Conversion Plant. Okay. Now, due to sun's heat, the there is a difference in temperature of water at the surface and at a depth. The temperature is not the same. Okay. So what happens? The temperature at the surface is hot, and deeper when you go, the temperature is less. So water is hot at the surface and cold when you go deeper. Okay. This difference in temperature is used to produce energy in OTEC plant. Now OTEC plant can only work if the temperature difference of water at surface and depth is 20 degrees. So water at surface and 2 kilometers below that. The difference, if it is 20 degrees Celsius, it will work, otherwise it won't work. Okay. Now you must be thinking, how does this work? So the warm water we take, this is the whole setup. We take a volatile liquid like ammonia, which easily gets boiling. So what will happen? Because of this temperature, ammonia starts boiling, it converts into vapors. The vapors, what they will do? They will move the turbine. The turbine moves, electricity generated. Okay, and because of this, you get electricity. Okay, the vapors of ammonia move the turbine. The cold water from the, now see what happens. So the cold water from depth of the well is pumped up. Okay, so the water which was hot, it evaporated. The more water came up. So it's a continuous process. Okay. This is the diagram of an OTEC plant. You can see. Okay, warm seawater and cold seawater are pumped to the evaporator and condenser. The cold fluid, working fluid is pumped to the evaporator. That is, this is the evaporator. Okay, the evaporator uses the warm water. I hope you can see. This is the warm water. This is the cold water. Okay. Now, so what will happen? The liquid, as I said, ammonia. So what will happen? Because of this, it will convert into vapors. Here is the liquid. So evaporator, what will happen? The vapors will come. They will move the turbine. It comes back. It again condenser is there. It again converts into liquid form, the ammonia. The ammonia again comes back. It again goes. So the water which is hot, it keeps on just generating electricity. I hope you understand this. Okay. Now next is geothermal energy. The word geo means earth. So energy obtained from the heat of earth is geothermal energy. Geothermal energy is not related, not based or not dependent on sun. So this is one energy which is not related with sun. Okay, sun is not a source of energy for this. Due to geological changes, the molten rocks formed in the deeper hot regions of Earth's crust are pushed upward and they get trapped. Inside the earth, the rocks are there in the molten form. They are moving. So what happens? Due to at some places they get stuck. These places are called as hot spot. Now when water comes into contact with that hot spot, molten rock, so water, what will happen to water? It will vaporize. Now that evaporized water, if it finds an outlet, it will go out. The water, the vapors will come out. You put a turbine there. The turbine will move. Electricity is generated.